So this was the last week test paper, questions related to electrical circuit. So in question 1, figure 9.1 shows a 12-volt battery which is connected in a circuit containing resistor A, B, and C. Each resistor is 6 ohm. We have to calculate a combined resistance of A and B. A and B are connected in series. A is 6 ohm, B is also 6. So whenever two resistors are connected in series, to get the combined resistance, we will add, so it will be 6 plus 6, 12. Then we need a combined resistance of A, B, and C. So A and B, the combined resistance of A and B is 12, and the combined resistance of C is 6. And it means like this is the combined resistance of A and B together, and the C is equals to 6 ohm. They are in parallel. So whenever we have resistor in parallel, the formula is a product divided by the sum. So it will be 6 multiplied by 12, 72, and divided by 18. So it will be 72 divided by 18. So this will give us 4 ohm. And whenever they are in parallel, the combined resistance always decreases. So the combined resistance of A, B, and C is equals to 4 ohms. And for resistor A, B, C, D, so the combined resistance of this whole part is equal to 4 ohm, we worked out, and this one is 6. So what is the combined resistance now? Because this whole part resistance is equals to, when A, B, and C, instead of A, B, and C, we have a combined resistance of 4 ohm, and this one is a combined resistance of 6 ohm. So 4 plus 6 or 6 plus 4, that is equals to 10. So combined resistance of A, B, and C is 10. This was 4, and this was the first one, because 6 ohm and 6 ohm are connected in series, so that was 12 ohm. So whenever resistors are connected in series, we simply add them. If they are in parallel, that is a product divided by sum. The current in the battery, if we want a current in the battery, we have the formula V equals IR. So V is the total voltage of a circuit. V is the total voltage of a circuit. R is the total resistance. So what is the total resistance of the circuit? When we work out for all of this part, the combined resistance is 10. So we want a current I. So we have the formula V equals IR. So the current I equals V divided by R. So V is the voltage, which is 12, and the resistance is 10. So 12 divided by 10, the total current which entered the circuit, that is 1.2 ampere. 1.2 ampere will enter, and same 1.2 ampere will leave. It will divide between the branches, but the same 1.2 ampere will leave the circuit. The last part, energy transfer from a battery in 50 seconds. So the formula for energy transfer, energy is equals to voltage into current into time, or power into time. The voltage of a supply, the total voltage is 12. The total current is 1.2, and for time it is 50 seconds. So we multiply all of them. So which is VIT, this will give us 720 joules. The second question, figure 8.1 shows 3 lamps and a fuse. The fuse is there to protect these lamps. The EMF of the supply, the voltage of a supply, that is 220, and each lamp is labeled 220 and 40 watt. Like the power of each lamp, the power of this lamp is 40, the power of the other lamp is also 40, the power of this lamp is also 40. And because they are all parallel, so they will receive the same voltage. If 220, so this lamp will receive 220, this will also receive 220 and 220. Calculate the current in each lamp. So the formula which relate the current, power, and voltage, that is power P equals VI. So the power of one lamp is 40, the voltage is 220, and the current we don't know. 220 is multiplied, other side it will be divided, so it will be 40 divided by 220. So 40 divided by 220, that's equal to 0.18. So the current here is 0.18 ampere. Then the second part, so in each lamp, because when we calculate the current here is 0.18 ampere. The second lamp also, because they all are identical, 0.18. The third lamp also 0.18. So what is the total current entering? 0.18 plus 0.18, 0.18. So it will be 3 multiplied by 0.18. That is the total current which enter the circuit. So 3 multiplied by 0.18, that is equals to 0.54 ampere. So the second part of a question is calculate the current in the fuse. The current in the fuse is actually the total current which we want. So in the first lamp, the current which we calculated by using a power was 0.18 amperes. The second lamp it was 0.18, and the third lamp it is also 0.18. And in parallel, the total current is the sum of current in each branch. So how much current is coming from the supply or the battery? So that is 0.18 multiplied by 3. So 0.18 multiplied by 3, that is equals to 0.54 amperes. Then total number of lamps which we can connect before the fuse blow. And the fuse rating is 2 ampere, means this is the maximum. Fuse rating means the maximum current which fuse can allow. So maximum current the fuse can allow 2 ampere. So how many lamps we can connect in parallel? So number of the lamps which can be connected in parallel until the fuse blows. So how we'll know? If we know the current in each lamp, that is 0.18 ampere, and we know the total current can be, maximum current can be 2. So how many lamps should be there? So the total 2 ampere divided by current in each lamp. So I will go get the number of the lamps. So 2 divided by 0.18. So how many lamps can be there? It is around 11.1. So 11.1, it means we can connect around 11 lamps. Because if I connect the 12th lamp, the current will be more than 2 ampere and the fuse will blow. So 11 lamps can be connected so that the fuse will not blow. Because fuse rating is 2 ampere, maximum it can allow 2 ampere, it allow. More than 2, it does not allow. So if the current is more than 2, the fuse will melt. So when we connect 11 lamps, because like as you can see, 11 multiplied by 0.18. So if 11 multiplied by 0.18, the current will be less than 2, which is 1.98. But if I connect the 12 lamp, like example 12 into 0.18, so 12 into 0.18, the current will be 2.16. So that 2.16 ampere is in more than 2 ampere, so the fuse will melt. So how many lamps we can connect? We can connect about 11 lamps. So the current will remain less than 2 or 2. If the 12th lamp is connected, the current will be more than 2 and the fuse will melt. Then after a very long period of a use, like when we are using it for a very long time, the filament of one of the lamp become thinner. Use the effect for this change on the resistance. What is the relation between resist? Because if it becomes thinner, it means area decreases. So what is the relation between resistance and area? They are inversely proportional. Thinner wires have high resistance than thicker wires. So as a result, what will happen? The resistance will increase. And state and explain the effect of this on the power of the lamp. Look, power is having 3 formulas. P equals VI, P equals I square R, or P is equals to V square over R. So when we compare what happened or what will be the effect, so you can explain, because here resist the formula in which only one of the variable is changing, that formula you can use to explain this question. So we cannot use this second formula. This formula cannot be used to explain what is happening. Why? Because both current and resistance are changing, so we cannot use to explain. Either we can use this P equals VI or P equals V square over R can be used to explain what is the effect of the on the power. So as you can see, as the filament become thinner, so area decrease, so resistance increase. As a result, resistance increase. What is the relation between resistance and current? They are inverse. If resistance is high, the current will be low. Like, because greater resistance, the charges cannot move easily. As a result, when current is, because they are all parallel, so they will receive the same voltage. So as a result, what happened? The current decrease, so the power will also decrease. So here the power will decrease. And why the power decreases? Because the current is decreasing. And why the current is decreasing? Because the resistance increases. Or you can also use this third formula, P equals V square over R. So V is constant. So what is the relation between power and resistance? So if the resistance is increasing, according to question, it becomes thinner. So resistance is increasing. So what happened to power? The power will decrease. So both ways you will get the same answer, that the power of the lamp or the bulb will decrease. In question 3, the circuit in figure 7.1 includes an immersion heater, 6 volts. State the name and the purpose of component X. So that is a variable resistor. And what is the purpose of the variable resistor? It is used to change the voltage or the current. The heater is designed to work 3.6 volts. So heater will work when the voltage across the heater is 3.6. So when the voltage is 3.6 volts, the heater will work. And it has a power of 4.5 watts. So the power of the heater, that is equals to 4.5 watts. By considering the current in the heater, calculate the resistance. So we have to calculate a resistance because component X and heater are connected in series. So whenever components are connected in series, they will have the same current. So if the total voltage is 6 and out of 6 if 3.6 voltage is across the heater, the remaining 2.4 voltage will be there across the component X. Why? Because they are in series. So in series the voltage divides. So if 3.6 across the heater, remaining 2.4 will be there across the component X, variable resistor. Now we want to calculate resistance. Resistance is a ratio between voltage and current. So we know the voltage, which is 2.4. We want a resistance of X. But we need a current. How to get the current? If we find the current in the heater, that will be same as the current in component X. So we'll use a formula P equals VI. P is the power 4.5. V is the voltage 3.6 and I is the current. 3.6 is multiplied, other side will be divided. So 4.5 divided by 3.6. So this will be 1.25 ampere. So 1.25 ampere is there, which is passing through the heater. Same 1.2 ampere will pass through the component X because they are in series. So 1.25 ampere is the total current in the circuit. So now we have the current, so we can find the resistance. We can solve this part. Resistance is the ratio between voltage and current. So voltage is 2.4 and the current is 1.25. So 2.4 divided by 1.25, that is equals to 1.92 ohms. So the resistance is equals to 1.92 ohm. And sometime after the heater is switched on, the ammeter reading have decreased. Why the ammeter reading have decreased? Because what happened? As the heater produce heat energy, so the temperature increases. And what is the relation between temperature and resistance of conductors? They are directly proportional. So as the temperature increases, the resistance will also increase. And what is the relation between resistance and current? They are inverse. So if the resistance increase, the current in the circuit will decrease. So if originally it was 1.25 ampere in the beginning of the experiment, but with the passage of the time as the temperature increase, resistance also increase. So the current in the circuit will start to decrease. So the answer for the part C, that the temperature increases, which increase the resistance and reduces the current. In question 4, in figure 9.1, there is a 12-volt supply which gives a current I. The circuit contains a thermistor. So this is a thermistor and a 1000 ohm resistor in parallel, and there's a 500 ohm resistor in series. At certain temperature, resistance of a thermistor is 1000. So if the resistance of a thermistor is 1000, we need the combined resistance of this part. So this one is 1000 ohms and 1000. So first these two 1000 ohm resistors are in parallel. What is the combined resistance? So product divided by sum. So 1000 into 1000 divided by 1000 plus 1000. So the product divided by sum will give us the combined resistance of this part. So when we solve, it will come out as 500 ohm. So this one is equal to 500 ohm. And now this 500 ohm is connected. So we need a combined resistance at a certain temperature. Thermistor is 1000 ohm. So we need a combined resistance of product divided by sum. So this part is equals to 500. The combined resistance of this whole part is 500 ohms. Then we need a current in the circuit. To need the current in the circuit, if we need the total current, we have the formula V equals IR. So V over R is equals to I. V is the total voltage. So V is the total voltage, which is 12. And R is the total resistance of a circuit. So when we work out, this is 1000 and 1000. So combined resistance of these two, when we find the combined resistance of these two components, so that is 500. So this one is 500 ohm because combined, and this is 500. So what is the total resistance now? The total resistance of a circuit is actually 1000 ohms. So we have the voltage is 12 and the total resistance is 1000. So 12 divided by 1000 will give us 0.012 amperes. So the total current which enter the circuit is equals to 0.01 ampere. So whenever we need a total current in the circuit, so it is always the total voltage divided by total resistance, or the EMF of a cell or a battery divided by the total resistance. So 0.012 is the total current. And then the potential across 500 ohm. So or voltage across 500. So what happened? Like we have 0.012 ampere enter the circuit, but in parallel it will divide, and here it will divide evenly. Why it will divide evenly? So 0.006 will be there ampere in this one and 0.006 ampere in the other one. Why it divide evenly? Because both resistors have the same resistance. But when it parallel branches and then it rejoin here, when it combined here, so it will be equal to 0.012 ampere. So we have the current and we have the resistance. So we can find the voltage using a formula V equals IR. So V is the voltage which is 500, V is the voltage which we want. Current is 0.012 multiplied by resistance is 500. So this will give us 0.012 times 500. So this will give us 6 volts. So the total 12 out of 12, this 6 volts here. So remaining 6 volts will be across these two, and they are in parallel. So 6 volt will be there across both of these parallel resistors. So this is a combination of a parallel and series. So what voltage drop here? Remaining voltage will be across the parallel combination. Then the temperature of a thermistor is increased so that the resistance, so that its resistance decrease. State the effect this will have on the current. So what will be the effect if the temperature is increasing? So resistance of a thermistor is decreasing. So what happened to the combined resistance? Like example, originally said it was 1000. When this was 1000, what was the combined resistance when we calculated? These two are in parallel, so they will be 500 plus 500. The combined resistance was equals to 1000 ohms when we calculated the combined. But now they're saying that the temperature increase, so resistance of a thermistor decreases. So example, say it is 100 ohm. Thermistor resistance change. So what is the combine of these two? 100 multiplied by 1000 divided by 1100. So the combined resistance of these two will be 90.9 ohm. And this is 500. So what happened? As the resistance of a thermistor is decreasing, the combined resistance of a circuit will be 590.9 ohm. So the combined resistance of a circuit is also decreasing. When the thermistor was having 1000 ohms, the resistance of the whole circuit was also 1000. But as the resistance of a thermistor decreased, the combined resistance of a circuit is also decreasing. And what is the effect of decreasing the resistance of a circuit? What happened to value of I? The value of the I, or the current which is passing through, will increase. So the total resistance of a circuit decreases. As a result, total resistance of a circuit decreases. The total current in the circuit will increase. Then in question 5, a student determines the resistance of a length of aluminum wire. She connects a wire in series with a battery and a variable resistor as shown. She knows that an ammeter and voltmeter are needed for the circuit. On a figure, draw a symbol for ammeter in a suitable position. So ammeters are always connected in series, so we should connect an ammeter in series. And voltmeter, if you want to connect a voltmeter, so voltmeter should always be in parallel. The variable resistor is included so that the current in the circuit may change. What is the advantage of able to change the current? So when we change the current, we'll have different values of a voltage and the current. And using this, we can repeat the experiment, or we can have a different results for voltage and current. So we can have more values for the voltage and the current. So as a result, when we'll have more values for voltage and current, it will be advantage. Why it will be an advantage? Because changing the value of a voltage and current, we can repeat the experiment and improve the experimental accuracy. Then the electricity is transmitted from a power station to a distant city using the aluminum cable of resistance 1.2 ohms. The power loss occurs because of the resistance. The current in the cable is 250. Calculate the power loss. The formula for power loss P is equals to I square R. So 250 current is there, square because it is I square multiplied by R, which is 1.2. So 250 times 1.2. So this will give us 75,000 watts. So 75,000 watt is actually the power which is lost in the transmission lines. An aluminum cable is replaced by a new aluminum cable of a same length. The current remains 250. The diameter of a cable is double. State and explain how the power loss is affected by this change. So we have the formula P is power loss is given by formula P equals I square R. The current is not changing. We are keeping the same current. So what happened because what is the relation between resistance and area? They are inverse. If you use a like a diameter of a cable is double. So if you use a large diameter, if diameter is double, the area will be 4 times because it varies with a square. So if area is increased by 4, resistance will decrease by 4. And if it will have a low resistance, it means less power will be wasted or loss. So to reduce the power loss, we try to prefer a low current and a low resistance. So how we can reduce the resistance by increasing the surface area. So thicker cables will have less resistance. This will have low resistance. This will have high resistance. And when low resistance is there, it reduces the power loss. If we are passing a same current like 250 amperes through each cable, the one which is thicker will have a low resistance. So it reduces the power loss in the form of heat. Then place one tick in each row of a table, indicate one use of a thermistor and one use of a, so thermistor is a heat detector. If it was LDR, then light detector, magnetic field detector, compass is there, rectifier, diode, and switch. We use transistor as a switch. Figure 9.1, lamp A not glowing brightly. Suggest and explain what could be done to component B to make the lamp A glow brightly. So what we should do, because we want more voltage across the lamp here. So this is a thermistor. This is a light dependent resistor LDR. So what we will do, if we increase the light intensity, what is the effect of increasing a light intensity on resistance of light dependent resistor? More light, it means it will have less resistance. This is a potential divider circuit. So in a potential divider circuit, the voltage divide between the component. If this is having a low resistance, so it will have a less voltage. And because if less voltage across the LDR, there will be more voltage across the fixed resistor, because it's a potential divider circuit. If one side voltage is low, the other side automatically the voltage will be high. And when there's a high voltage, they are connected in parallel, so there will be more voltage or high voltage across A. So high voltage across A, so it will be bright. So what we should do to glow this lamp brightly, we should increase the light intensity, which lower the resistance of LDR, or voltage across LDR will decrease. So more voltage across the lamp. As more voltage across the lamp will glow brightly. So this is the last question. Figure 8.1 shows a 12-volt battery which is connected to a resistor and a component X is in series. Identify component X. So what is this component X? That is called a diode. So X is actually a diode. Then there's a potential across 4 ohm resistor is, so they are connected in series. If across 4 ohm resistor, it is 11.3 according to question. What is the potential across X? So if out of 12, because they are connected in series, so if out of 12, 11.3 volts across the fixed resistor, how much voltage is across the diode? So remaining will be there across diode. So 12 minus 11.3. So 0.7 volts is there across the diode. So potential across the diode or voltage across the diode is equals to 0.7 volts. Then we need a current in 4 ohm resistor. How to get the current? We have the resistance and we have the voltage. So we can use a formula V equals IR. So I equals V over R, where V is the voltage 11.3 and R is the resistance, that is 4. So 11.3 divided by 4. That's equal to 2.82 ampere. So 2.82 ampere is the current which flow through this circuit. The next part, the figure in the circuit in figure 8.1 is now modified as shown. The current in 8 ohm resistor. So what will the current in 8 ohm resistor? This one is 12. So the total voltage between them is 12 and total voltage across 8 ohm is also 12 because this is in parallel to the battery. So same voltage will be there. Then we'll use a formula V equals IR. So V is equals to IR. V is the voltage which is 12. I is the current which we are finding and R is the resistance 8. So it will be 12 divided by 8. So 12 divided by 8 is equals to 1.5 ampere. Then current in the battery. How we can find the current in the battery? As we already calculated, because current in the battery will be the sum of the current in as they're in parallel. So we calculated the current was 2.82 ampere here, and we calculated the current is 1.5 ampere in this one. So what is the current entering from the battery? The total current will divide between the two branches. So it will be the sum of 1.5 plus 2.8. So that is equals to 4.3 ampere. So this will be 4.3 amperes. So this was the last week test related to electrical circuits.